So far, to create our visualizations, we have very heavily relied on really recreating the charts that Du Bois and his team had made. And what that meant in the case of our bar chart is that we specifically measured the width and the height of the actual bars in the original example and kind of translated that to pixels and recreated the chart as such. But of course, in most visualization contexts, in practice, that's not a viable approach because actually the chart doesn't exist yet. So we can't measure the width and the height of the bar elements, let's say. And so to do that, what you want to do is you want to take some kind of data variable, in our case population, and you want to somehow translate that variable to some pixel measurement. Or in the case of, to use the right kind of terms and concepts, in the case of the Munzner reading that we've done for class, we want to translate the data variable to a particular channel, in this case, the width of the rectangle. And we do that through a process that's often referred to as scaling or mapping. And we map or scale from our data space to a pixel or screen space, if you will. There's all kinds of different ways of doing that, but one of the most common ways of doing that is using the D3.js ecosystem. Now, as you can read in the class materials for this week, that's a very large ecosystem that will help us do all kinds of different kind of aspects of data visualization. For now, we're going to concern ourselves with only with the D3 scale library, which you can read here on GitHub, is basically a series of convenient scaling functions and tools that will allow us to do exactly what we need to do, namely scale from a data space to a screen or pixel space. But to use that, we need to be able to actually first install it and subsequently import it into our project. So that's what we will cover in this section. And then after we've imported it, we will actually use it to no longer rely on the measurements that we have taken earlier, but just straight up translate the population number to the right amount of pixels for our bars and rectangles. So there's a few steps that we will walk through. First, we will use npm to install this library called D3 Scale. Then we will import D3 Scale in our app.svelte component. And then we will create an actual scaling function to go from our data space to our pixel space, and then replace old population underscore pixel reference or variable with newly scaled population value. All right, so those are the 4 steps that we're going to walk through. First, we would like to install this library. Now we know that it exists on GitHub, and on most JavaScript GitHub repositories, you will find some instructions on how to install it, and very often you'll see something that looks like this right here, npm install, and then the name of the library, and that's what we're going to use too. So I'm gonna switch back to VS Code, and I'm going to open a new terminal, a clean terminal. And all I need to do to actually install D3 Scale as a dependency in my project is just type npm install D3-scale. Hit enter. Again, it will go online, it will look for the right kind of source for the package, and then it will download it. There you go, and add it to your project. You can always check if that was successful by actually going into package.json, and what you should see but I'm not seeing that right now, and that's, I think, because there was actually a small error here relating to the optional dependencies that weren't installed. But that's fine. We're just going to ignore that error for now because it actually has installed D3 skill, so we should be able to actually use it. But we'll find out now, because the next step after you've installed it is to actually import it. So this is a little bit similar to what you already know from the R universe, where in R, to install a package, you use install.packages and then the name of the package. But to actually use it in your project, you use the library function. Here we use the import logic. On the class website, you should see a reference to the MDN documentation, but the import syntax is relatively straightforward. We use the import keyword and then which functions we want to import from that particular library between curly braces, and then from, and then the name of the actual library. So let's see how that actually works in practice. I'm going to type import and then the name of the function. In this case, we want to use linear scaling. You can also do logarithmic scaling, etc. But we're not going to deal with that as of yet. And then I want to install that from D3 skill. So this will now make available this linear scaling under the name skill linear. So what I should now be able to do is actually use that skill linear function to construct a scaling function and store that as with some kind of reference. So in this case, let's create a reference that we call width skill. We use the skill linear function, and then the linear scale function needs two essential ingredients. It needs a domain, and the domain is basically the minimum and the maximum of the data domain or the data space, and the range is the minimum and the maximum of the screen space. So that's basically the output space, and the domain is the input space. So in this case, as you can see in the class example, the domain goes from 0 people, 0 African Americans in our specific case, to about 7.5 million people that are present in the United States in that last decade, 1890. And the range goes from 0 to 407. Now these values I've actually just lifted from our original code, and I'll show you that now. You can see here the minimum of our data. Our first value is 220,000, but for good measure, we just started at 0. And then the last one here, this is where that 7.5 million is. And we can see here too, that population in pixel here was 407, right? So that's the same values that I'm using here. And I'm just going to go all the way to the bottom of my script here and paste in that little bit of code that we had earlier. So we have width skill and then skill linear, and then we give it two additional kind of properties, if you will. We set the domain to 0 to 7.5 million and a range to 0 to 407. So I'm going to save that just to make sure we don't get any errors, which we don't. So that looks good. There we go. And then we should be able now to replace our original bar width here. We had the width argument or property on our rectangles, and the value of that was item.population_pixels. So that was that thing that we had pre-measured. But what we can now do is we can make reference to our width scale, and that is a function, and the function takes as its input some value in data space. So in this case, that value is actually the actual population, and it will output the value in screen space. So it will take any value that's between 0 and 7.5 million people, and it will output some number of pixels that's between 0 and 407 pixels. Now, if I hit save here, you should see a very small change in the actual width of the bars, and that's because the boys in his team did things by hand, so they didn't have a pure kind of mathematical scaling function, but now we do. So now everything is consistent. So now we no longer make reference to this item dot population underscore pixels, but just to the actual population. So that actually means that all of these population underscore pixel things can now be removed from our data set. So we should be able to actually remove all of these, and the chart should still draw, which is a nice test. So there's only 14 of this, so we can do it pretty fast. Almost there. And last one. All right, so I've removed the pixel values from my data set, so I save now, and then there we go. So I still have now the chart drawn even without that measurement. So to go back to our to-do list, make sure we have covered everything. So first we installed this new library with the npm install command that made it available in our project, but to actually use it, we had to import it using the import syntax. Then after importation, we can use it to create a scaling function. Now D3 scaling functions take these two important kind of ingredients, the domain, the minimum and the maximum of the data space, and the range, the minimum and the maximum of the screen space, if you will. And then once we have that scaling function, we could use it to calculate the pixel values of the bar width instead of relying on something that is pre-measured.